Hello and welcome to another tutorial. So this is actually the first in series we're going to be branching out a bit from covering Unity and the C# side of things to starting to take a bit of a look at the C++ side of things. So the plan is that going to be out of every sort of block of tutorials that I do, there's still primarily going to be Unity and C# ones. That's the area I still want to be doing a lot of, but starting to bring in a couple of little bits at times of things like C++, building up a bit of knowledge there for folks with that, because I think in particular, if you're wanting to focus on the programming side, it's really handy to be multilingual. Really strongly encourage programmers to be multilingual. So knowing multiple languages is really beneficial, because sometimes there are things that it's easier to do in one language versus another. So having that experience with a range of ones is really beneficial. So we're going to start with the very basics with C++, and over time we'll start to look at more advanced topics. As I said, the C++ stuff, every sort of block of about 8 tutorials, there'll be one or two ones in there that'll be C++ focused generally. So, okay, we're going to start with creating a project. Now, with this, I'm going to be showing this using Visual Studio. Now, a couple of the bits of setup that I'm going to do are obviously going to be very specific to Visual Studio, but the actual code that I'm writing won't be. So that's something where I'll be making a point of the code that I will be writing will be tool agnostic. So it'll work whether you're using Visual Studio's compiler, whether you're using something like GCC, any of the other ones, LLVM from memory. There's a bunch of different ones there. So the idea is that this code will be portable. And C++, it's pretty easy for making the code portable generally. So, okay, I'm going to create a new project. So I want to go to create new project. And from the templates, you can filter by language here. By default, it may be showing all languages or like a C#. I want to go to C++. And then the one I want to use is something called a console app. So a console app, it's going to be text only is what we're seeing. And it'll pop up a little window that has that text in it. So console app is a good sort of starting point for working with most of the stuff in. So I'll go next, and then it'll ask for a name, a folder where it's going to place stuff in. It does, based upon your project name, create a folder under that. So for example, I'm going to call this C++ tutorial introduction. I'm getting started. So we go create, and we see it created the folder there. And then this is what we see to begin with. So with C++, and a lot of, when I'm talking about the C++ side of things here, I will give a rundown in particular with C++, but where it's applicable, I'll also talk about how that contrasts with C#. So if you're coming from a C# background, then I'll be sort of explaining the bits that are similar to it. So this is what we get as our starting file. And straight away, there's a couple of differences that we see compared to C#. I know a lot of the syntax will look similar, but there are bits that look different. So going through the general structure of this, we've got areas here that are commented out. So a double / comments out a single line. You may also see things where there is /* and then a */. That allows me to have multiple lines of code commented out. Comment. So we've got a lot of stuff commented out there, which these are really handy. So are the single line ones. So, okay, we've got that. Then we've got this thing up the top here, include. So if you're coming from a C# background, you have likely seen the using statements at the top of a project. And you might see something where it's like using Unity Engine.networking. So if you were doing web communications, you would bring that in. If you were wanting to do a bunch of UI stuff and to make it a bit shorter what you're having to type, you might bring in Unity Engine UI or bring in TextMesh Pro. Includes serve a similar purpose. So includes bring in functionality. How they work is quite different to a using. So the way a hash include works, broadly speaking, is that file. So IOStream is an actual file that we could open and look at. It goes to that file. It selects the entire contents of it and effectively pastes it in here when it's doing the compiling. And that include might include other things. And that's something where when we get to looking at header files, there's some stuff that we can do there to prevent circular references. So what we're doing here is we're including what's called a header file. So that brings in extra functionality. Then we have this thing here, which if you're coming from a C# background, you would recognize that this is a function, but you wouldn't have likely seen a function like this, because for starters, this isn't inside a class, which we're used to seeing in C#. This is sitting outside of everything. So with a C++ program, and actually any program has this, it's just generally with things like a Unity project, we don't actually ever see this. But every program has some equivalent of this. There has to be, when you launch a program, an entry point, somewhere where the execution of the code begins. In C++ applications, that is the main function, is what it's referred to as. And that always has an integer return value. So this is a function called main that returns an integer. That means when we run this application, whatever has run it can actually get that number back, and that number can have meaning, which is really handy. So that's something that can be really useful. So that gets used by console applications, command line applications, you might also have heard them referred to as. That gets used by them as a way to indicate what's happened. Has something been successful? Has it failed? If it's failed, how has it failed? So our main function is the entry point for our code. And it has to be called main. It has to follow this sort of structure. There are some limited cases where we can vary this that we'll look at a later point in time, but this is the general structure. It has to be called main, returns an integer, and this is where our execution of code begins. So if I want to run this in Visual Studio, the easy way to do that is I can just hit F5. So it then compiles it, and we can see its output, hello world, and by default, it's not going to automatically close the window, which is handy. So that's something to be aware of. If it does immediately close on you, there will be settings that you can adjust so that it doesn't, because we want to be able to see the output, obviously. So we can see hello world appeared, and if I press a key, then it closes. So hello world is being output from this. So again, in C#, we're used to seeing, in Unity in particular, we're used to seeing debug.log or something similar to that. In C++, when we want to output stuff to the screen, we do have a range of methods available. But one of the things that IOStream gives us access to is this standard cout. Cout is short for console output, and std is short for standard. So within C++, there is something referred to as the Standard Template Library, or STL. The STL contains a wide range of classes, of functions, of utilities to do different things. So IOStream is part of that, and IOStream gives us the ability to do stuff with things like the console. So the reason it's called IOStream is that's short for input, output, stream. So it can be used for reading stuff in, can also be used for writing stuff out. And this concept of a stream, a stream in C++ is anything that data can be sent to or read from, really. They're quite a broad thing. So the console can be treated as a stream. Our keyboard is a stream. So if we want to read in, we can read in from the keyboard stream, which is referred to as console input. We also can work with files in that way. So it actually is really powerful because you write the stream code essentially once in most cases, and then it works for displaying on the screen, outputting to a file, reading in from a file, sending over a network as well. You can have similar processes there for all of these things. So streams are a really, really powerful tool for working with. So standard cout is the stream that refers to the console. And what it's saying is, and so the double left or double less than, that means that we're saying that's the stream insertion operator. So it's saying insert hello world into the cout stream. So if we wanted to start changing this, let's start making it so that maybe we want to bring in the person's name and then we want to actually, say hello to that particular person. So for that, if I'm wanting to read in a name, that would be going into a string. So unlike in C# where there's a lot of stuff that we've already got there accessible by default, that's not the case in C++. So to access strings, we need to bring in string. And you might see sometimes the headers will have .h, other ones don't. Generally, the way that breaks down is things that are part of the standard template library won't have a .h, whereas ones that are often your own created ones will have a .h. So that's generally how it works with that. So I need to set up my variable. So if I want to store this string, so I can have standard string name. So you'll notice a lot of things are getting prefixed with this std. So this is saying it's in that namespace. Now something we can do, if we're having to write this a lot, that does get annoying and it does get messy, can make the code a bit harder to read. Something we can do is we can write using namespace std. That allows us to get rid of these. Now we do need to be very careful with using things like of this, because we can using lots of namespaces, but part of the reason for having namespaces is to have separation between variables. Because if you think of something like on a large project, a very large project might have the core engine, and that might have a variable type that can hold positions, and it might just be called position. But then you have an audio library. Well, it needs positions as well. It might call it the same. Physics, lots of different sides of things there might have a variable called position, and they might represent that differently. So namespaces are a way of having it that those things can be named the same, but they're not going to clash. But if we're using in all of those, then it has no way of knowing which one is which, and we can get clashes there, and that can cause quite serious issues. So we do want to be very careful when we do something like of this. We can actually even do that within the function here if we wanted, but for now I'll put it up here. So I've created the variable. I want to read that in, so I'm going to display a bit of a prompt. Please enter your name. Then I'm going to cin to name, so console input stream, and that's the stream insertion operator. This is our stream extraction operator. Because then down here, I'm going to change this to say hello. And this is one of the nice things with streams. You just keep chaining things together. So we can then do that. And if I want to just put an end of line, what I would actually use is this thing called endl, E-N-D-L, end of line. Line endings vary depending upon the operating system you are running on. Endl will always correspond to the correct line ending for the platform that you are running on. So we'd always recommend using endl over using something like \n, just as a way of actually sort of ensuring you're avoiding potential issues there. So let's test this out. So we've got our variable. So variables hold information. So anytime we need to hold information, we use a variable for doing that. So we've created a variable that's of type string, and it's called name. Then we're saying, enter our name, we read that in, and then we're going to display that out. So I'm going to hit F5 to run this. So it's asking for the name. So I can put my name in, and then it says, hello, and then the name. So that's good. Now I would put in some comments for this. This is going to be more verbosely commented than I normally would, but gives you then that as a bit more of a reference. And this is something I'll make sure I do with any of these earlier tutorials. They will be very verbosely commented. I do recommend something when you're early starting out working on stuff. Write out the comments to describe what you're trying to do first, and then try and implement the code. Coding is not just a singular task. When we're writing code to solve something, there's actually two stages to that. The first stage is working out, well, what are the steps to solve this problem? And then the second stage is, okay, what does the code for that step look like? And it's very easy when you're starting out with programming in a language to get roadblocked because you're trying to do those two things simultaneously. And eventually you will hit a point where you can do that, but that takes experience, and in particular takes building up essentially a library in your head of, oh, okay, this step looks like this code. And that only comes from building up a lot of code over time. So we need experience to get to that stage. So early on, use comments to describe what you are intending to do to plan out your steps, and then write the code to address those comments. That can really help early on, in particular if you find that you're sort of spinning your wheels, getting stuck with sort of setting things up. That can make a big difference. So for this one, we are creating a variable called name of type string. Then we are asking the user enter their name, read in the name, and then we greet the user. So, okay, good so far. We've created our variable. We're doing a bit of basic stuff there. Let's look at working with a couple of other simple variable types. I think is a useful thing to see. So, okay, that a string is good for holding text, for holding sentences, names, words, things like that. What if we want to hold a number? Well, if we want to hold a number, we've actually got a lot of different options because it depends upon the type of number we're holding. So what I mean by type is one of the first big things is, do we need decimal places or not? If we don't need decimal places, then what we're looking at is an integer type. So we would have something like int, so say for someone's age. So we might have age. We'd use an integer. If we were looking at something where we were describing maybe the speed of something, well, speed, that we probably should have decimal value support for that. So that we would use something typically called a float. Now, we do have multiple different types for each of these. So something like an integer that is 32 bits in size, or 4 bytes, which what that means is an integer, if we're allowing it to store positive and negative numbers, that can range from about -2 billion up to positive 2 billion. If we're only doing unsigned numbers, so only positive numbers, then we would be looking at it going from 0 to 4 billion. Floats can handle a very, very wide range of numbers, but a float has limits on how precisely it represents a number. Broadly, 3 to 4 decimal places is sort of what you're looking at with a float. So there is inaccuracy there in floats, and that is something that actually comes into play for games with very large environments. If you have games with very large environments and you move very far from the origin, unless you do some nifty tricks, you can actually get into a state where your geometry kind of explodes, because at the very large values, the increments in terms of, okay, we might be representing this floating point number, the next one that we might be able to represent, the nearest closest one might be 100 meters away, rather than the 10 centimeters we expected it to be. So floats do run into issues when we need a lot of precision. So that's something where we can use a double instead. So we might use that for something like time, and I might call that current time. So a double also stores decimal values, stores them with a higher precision. So whereas a float is typically 32 bits, a double is double that, so 64 bits. So significantly larger amount of data that it's storing there, so much higher precision, much wider range. So be sort of mindful with that of what types you're wanting to use, but larger types also are slower to process. So something like a double takes up more space in memory, takes up more time to process it. So we use floats where we can, but at times we might need to go to doubles for some things for that precision. Now, if you've come from C#, then those variables, if I just output them now, so if I go age, and I can just do like that, then put in a new line. I'm going to just copy and paste that to make it a little bit quicker for each of these. And I'm just then going to run it. Haven't put any values in them, anything like of that. Now we do get a little bit of an error, and that's because we haven't initialized them. Now this is something where in C# that wouldn't happen, and if we had our error levels tuned lower, it also would actually still let this run. So the warning levels are high enough that if there's an uninitialized variable, so uninitialized meaning we have not ever assigned it a value, we've not initialized it, it won't actually run. It considers that an error. That will not always be the case. We could turn off that restriction. We also could be using a compiler with different settings, so it might have different restrictions there, and it might allow us to actually output it. In C#, this wouldn't be an issue, because in C#, variables are always initialized by default. That doesn't happen in C++. If I turned off that error and ran this, the contents of these is arbitrary, it's random. It would be whatever happens to be in memory at that particular location. And that can be a massive, massive problem, because that can mean we've got bad data getting in there, can mean security risks as well with stuff being uninitialized. So we want to be in the habit of making sure we initialize things. Now you'll notice also, if you've come from C#, you would have expected me to have to put the F here for indicating that it's a float. C++ is a little bit looser with its type conversions. It's a little bit looser with its type conversions, so things like this, it's not generally going to get grumpy at you over. And this is something that we will run into with C++. C# imposes a bit more restrictions on what we can do, and as a result, there's a whole range of errors it's harder to run into with it. C++ kind of takes more of a step back and it's like, yeah, we'll see what happens. So that means a lot more stuff can go wrong with it. But that's okay, because we'll look at ways of how we can go and track those down and find them and fix them. So let's run this now. So I can enter my name, outputs the variables. It is still going to tend to truncate stuff like the double a little bit, but we can override that and control how many decimal places appear. We will have also seen, and it did, if I try and delete the build again, which if I just make something slightly different, and just rather than running it, if I just go build solution, we'll see it does warn at least. So although I don't have to put the F there, without it, it does treat that as a double like in C#. It just largely handles it and we just get a warning for it. So I want to generally, where it is definitely a float, good to actually put in the F there to indicate it. So that's good. We can hold some basic types. We can do some simple outputting of them. So we've seen how we can do that. We can also do mathematics and calculations on these if we needed to. So for example, we could do speed multiplies equals. That will actually multiply speed by, say I put 2 here. That will take speed. That will multiply it by 2 and write that value back into the speed variable. So if I run this now, and I'm just going to need to enter in my name, you can see the speed is double. So we can just do direct changes like that. Current time. So as well as having times equals, there is all of the other ones there as well. So we could have current time divided by 0.5. We could do then current time plus equals 1. So this multiplies speed by 2 and updates the variable. Now you will at times see things where you will get a red line where it's going and indicating issues. So in this case, you can see it was getting grumpy with there being the F there. That's because, whereas C# would allow that, I would need to put a decimal there. So if you put F and there isn't actually a decimal point, which we just need the decimal point there, we don't need to have any values after it, but if you put F without the decimal, it's going to complain. So it is a little bit sort of more particular in some ways than C# than that. So this one multiplies speed by 2, divides time by 0.5, i.e. multiplies by 2, which is effectively what it's doing, and updates the variable. This one adds 1 to current time and updates the variable. Make sure that's in there. And as a final one, we could also just do speed. Well, that's equal to speed times 5. So we can also just do, okay, it's equal to, and then do the calculations on this side. But these times equals, divide equals, plus equals, you've also got minus equals, you've got a bunch of different ones there. Those make it really easy for being able to just quickly update something, and it allows us to write much shorter code. It's a little bit easier to read as well, like that. Okay, speed is being multiplied by 2. Whereas with this one, okay, speed is being set to speed times 5. So it's a bit more intricate, a bit more involved. So these simpler operators can be really handy. So if I run that, I enter in my name, and we can see it's got the updated values there. So that's good. We've seen a couple of things for getting input in, for getting and displaying stuff, for working with some basic variables, and doing a couple of key little elements there with this. So what I would recommend is dive in and experiment with this. If you want, grab this code, start to make some modifications and changes to it. With coding, especially if you're just starting out, experimenting with the coding and just writing stuff is one of the best things that you can do. And early on, it's going to be very repetitious. It's going to be a lot of writing the same very simple things. That's actually the point. Programming is something you need to practice. It's like learning anything, but the thing I often compare it to is stuff like learning an instrument. When you are learning to play an instrument, unless you have some phenomenal level of innate talent, which I've seen people like that, and it's just astonishing to see. It's just incredible. But unless you have that with coding, it takes time. And so like learning an instrument, you have to sound terrible for a while. My neighbors can probably verify this from me playing the keyboard. But you have to sound terrible for a while, and then you get better. And you get better, and you get better. And early on, it's a lot of repetition. It's a lot of rote. Okay, do this. Yep, keep going, doing the same thing. And that's what we have to do with programming. So we have to sit down, we have to persist with it, we have to practice it. And we have to sound terrible for a while. We have to make things that are going to break. We have to run into problems so that we can start to build up that mental knowledge of what is our solution for this. So early on when you're experimenting with the programming, if you run into errors, that's a good thing. The difference between someone who's just starting out programming and someone who's been programming for, say, 10, 20 years is the range of errors they've run into. The person who's been programming for longer has run into so many more errors and run into them so many more times that it's become a reflex, essentially, of, oh, it's this error. Okay, here's the solution. Or, okay, it's this type of error. Here's my process for tracking down and fixing it. And so the earlier you can start building that up, the better. So embrace running into errors with the code. Embrace things going wrong with it. That's part of the process. And just keep doing that. If you're running into errors, that's good, because that gives us things that we can focus on fixing. So dive in and experiment with it. See what sort of things you can be trying to do with the code. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out. It's really appreciated. If I've got any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub. And that code you can freely use that in any of your own projects, commercial, non-commercial ones. You're able to be making use of it. This tutorial, I've got a link as well in the description to a video archive. So the video archive is something that's searchable, where you can be finding any of the videos that have been done. You can search based upon the descriptions. They're all grouped into more categories as well. So that's something that, if you're looking for a particular thing, is something to check out. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time, bye.